Hello and welcome to this video where I want to talk about how this heavy metal thing can fly. So here we have a huge plane, it's made of metal. The question is, how can it stay up in the air? Okay, so the trick is wings, but not these wings, although chicken wings are really awesome. And not those wings either, although those are very cool. It's actually these wings, so the wings that we put on planes. These are the reasons why planes can fly. You won't find any planes without any wings. That's just a rocket. So if we look at the side view, we want to look at the wing itself as seen from the side to explain why the wings make the plane fly. So basically this is what we want to focus on. But let's look in a more 2D side cut way of looking at this wing. So this is the 2D view of a wing. We're looking at it basically from the fuselage of the plane and then out to the tip. And it has a very specific shape, which is important to make the plane fly. So air is a fluid, so it has density, it has particles, and that is what's necessary to generate the lift. So the wing has a top side and the bottom side, and the distance on top is longer than the distance on bottom. So the air that goes over the wing has to travel further than the air that travels below the wing. And that's really where the key is. Um, there is when you have air or when you have fluids moving at different speeds, they have different pressures. So if you have something that's going faster, it has lower pressure. And then if you have something that goes slower, it has higher pressure. So the geometry of the wing and the fact that it's being propelled through the fluid, which is air in this case, um, with an engine. So the engine makes a certain velocity of the wing, pushes the wing through the air, and because the air is flowing faster over the wing than under the wing, it generates a pressure differential between the top side and the bottom side. So you have higher pressure below the wing than above, and this creates a differential pressure, which creates a force that pushes. So that kind of looks like this. So you have the lower pressure on top with these small arrows, and then you have the slower air on bottom with the bigger arrows. So where's the wing gonna go? Well, you have more force below it, so it's gonna want to go. It's gonna be like a tug of war between the small force on top and the large force on bottom. So the big force is gonna win out. So it's gonna push up, and that's what we call lift. So when you go fast, when you have this wing going fast through the air, it will generate lift because of the differential pressures that are created based on the different speeds. So, showed in a more complicated way, you have an upper airstream, which is the reddish color, and you have a lower, um, well, streamline, airstream. Anyway, upper streamline and the lower streamline um, with different pressures. The blue one is the slower air at the higher pressure, and the red one is the faster air at the lower pressure. That generates lift, and then you have the airplane path, which is just, the plane is flying to the left. This is the wing of the plane, and the plane is flying to the left. If we want to talk about a more mathematical expression of this, this reality or this physical phenomena, we refer to the Bernoulli's equation. And he has an equation that explains this mathematically, this fact. So we have P1, which is the pressure at a certain elevation, elevation 1, and then half rho, which is fluid density, the density of the fluid, V1, which is the velocity at elevation 1, to the power of 2, plus density again, G, which is the gravitational constant, acceleration due to gravity, and H1, which is the height of elevation 1, and then P2 is the pressure at elevation 2, and then plus 1/2 of density again, V2, which is the velocity at elevation 2 to the power of 2, plus rho, which is the density, g, gravitational constant, h2, which is height of elevation 2. So if you look at each part of that, so the P is the pressure energy. This is the static pressure. And then we have this part, which is the kinetic energy, the dynamic pressure. And then we have this part, which is the hydrostatic pressure, so the potential energy. So it's the density with the gravitational constant times the height of the fluid column. And for along a certain streamline, this is constant. This value is constant. And when you call streamline, we're talking about these lines. They're called streamlines. This is constant along a streamline. Yeah, so in summary, this big metal thing can fly through the air, and even better, just to win humanity over animals, you don't even need to do any flapping. So take that, birds. Thank you.